So as you can tell, probably from the picture here, these moons of Neptune are not going to be as interesting of worlds as some of the other planets' moons in the past. This basically looks like a rock. That's one of the moons we'll look at. This one basically looks like a big rock, too. That's another one. There's really only one moon of Neptune that we really want to spend a lot of time looking at, and that's this guy. It's Triton. And we'll get to that shortly. But first, the first relevant moon from Neptune is known as Larissa. That's the best picture that we have of Larissa.
Why do they name everything else like weird things and then Larissa?
Kind of looks like a shell if you look at it, right? Like the ends of the shell. So this is the first moon from Neptune, Larissa. Eventually this is going to work. So you're going to want to write this part down here. Named after a famous sea nymph. Now here's the real question. Obviously this is Ariel from Little Mermaid. The real question is, which video game did I pull this image from? Well done. Which video game did I pull this image from? It's for the PS2. If anybody remembers that system.
It looks like some computer game from the 2000s.
It does, and it is. Starts with K, that's the first letter, and the sequel just came out.
Is it Kingdom Hearts?
Yes, it is.
Wow, she said that.
Yep. This is from the Kingdom Hearts video game.
I never seen it.
Yeah. As time goes on, I find that gets guessed less and less. But I think last year they figured it out. So you can skip the size, but it's very, very small. When I drive from Milwaukee to where my parents live in Oshkosh, it's about 100 miles. And this is just a little bit bigger than that on average. You can write this down, cratered, rocky, and icy. These are two very close-up images that we do have of it, so that's kind of nice. One other thing that's kind of interesting about little Larissa here is it's not going to last all that much longer. Its orbital radius is slowly getting smaller. So as it goes around Neptune, each time it does so, it actually gets closer and closer to Neptune. So eventually it'll probably fall into the planet. Go ahead and write these two down as well. I'm not quite sure the measurements, actually. That's a good question. I'd have to look into that. But overall, it is getting closer and closer. So eventually, using physics, it would eventually fall into Neptune. I don't think it'll occur in our lifetime, but... All right. This is the big moon of Neptune that we have to pay attention to. So you can write this one down.
Are we gonna have to know them in order?
Yes, you should know the order. The good part about these moons is we're only going to look at 3. You can write this one down too. This image taken from the same video game.
Right, both of them or just the first one?
Both of them. Yep, do both. Of course, the reason they decided to name Triton after the son of Neptune is because it is the largest moon that is going around Neptune. So they had to give it some extra importance. Just like on Saturn, they gave Titan a lot of extra importance too, because it's the biggest, most prominent moon going around Saturn. So yeah, you've got the son of Neptune here. He is the god of the sea, as opposed to the god of the whole ocean, which is what Neptune is. You can write down this size. Much, much larger than Larissa. What's it? No. Yeah. So this is a pretty big moon when you compare it with Neptune's other moons. Although it is probably a pretty average-sized moon if you look at the other large ones in the solar system. This is about the same size as a lot of Jupiters and a lot of Saturns, too. You can write down the surface, icy and rocky. You can see Neptune in the background there. It's like a winter wonderland in some places.
You said right there, right?
Yep. What about Neptune? What about Neptune is incorrect about this picture? The rings. You would not be able to see the rings if you were standing on Triton. They are there, but in order to see these rings, you actually have to have Neptune being backlit by the sun. You're not going to see it in the daytime. You have to have very special conditions to notice that they're there. Interesting little picture here. Another one right here of what Neptune would look like if you're standing on Triton. It would be just a massive, massive blue ball. What's this? Oh, these are just some surface features. Oh, they just put some people in. The other cool thing about this is, again, remember how small the sun has gotten now that we're so far away. Even during the day, you're going to be able to see lots of cool stars here. So that is pretty accurate about this picture. Another one. It's a neat picture, but again, you wouldn't see those rings. And there's a pretty big difference in size of how they're viewing Neptune. They don't pay too much attention to that. Comparing the two, I would say this one is probably the more accurate of the two. Okay. I'll tell you from this slide, I want you to write down that Triton has a lot of surface features. Triton has a lot of surface features. You don't have to write down each one, just say that it has a bunch. The most important thing that you would notice, though, if you are coming up on this moon and you don't know where you are in the solar system, the first thing that would probably strike your mind about it is that it looks kind of like a cantaloupe. Go ahead and write down cantaloupe terrain. It does look a little off, doesn't it?
I didn't know it was called.
Cantaloupe.
Right there, that's the terrain.
Yep, cantaloupe terrain. Now I'm going to go back a slide here. Any thoughts or guesses as to what these like black streak looking things are? Any guesses on what we're seeing there? What's that? Hollows? Could it be like a shadow from some hollows there? Let me ask a different question. What do these all pretty much have in common? They're boring. They what? They're all plural. I mean, like I'm talking about the little dark things here. What's kind of a big similarity? Like you can see them here and here and here and here. There.
They're all going the same direction.
All going the same direction. And because they're all going the same direction, that indicates something that's very, very important about this moon. If they're all going the same direction, chances are there's wind that's blowing them in that same direction. And so this is the only other moon in the solar system, aside from Titan, that actually has an atmosphere. Write down that Triton has a thin atmosphere. And if we do a zoomed-in picture, a lot of times when we have planets that have real thin atmospheres, you can see just a small amount of discoloration between the actual surface and where space would be located. And that's what this image shows here. This is the surface of Triton. You got space, and you've got this little kind of discoloration between the two. This is that thin atmosphere that Triton has. Interesting artistic picture there. Also on Triton, we've got cryogeysers. Write this down. Nitrogen is what they're blasting up into space. Now again, these cryogeysers are different from things occurring on Earth. When stuff comes out from inside the Earth, it's magma, it's melted rock, it's lava. If we're talking about Enceladus, which is going around Uranus, then we're talking about water and other volatiles that are being exploded out. But here on Triton, we've got nitrogen as the primary thing that is being spewed out from the inside. And that is what we're seeing in these dark locations here. These are cryogeysers, and the reason they look so dark isn't because nitrogen is just dark. The reason is because they're coming out with such force that it's bringing up a lot of the rock and the dirt from inside the moon itself, and it's being blown along by the wind in those directions. And this is just a little diagram of what's happening. The crust of this moon is open in certain locations, and wherever it's open, that high pressure is going to find its way out, and it does so. If you're standing on Triton, it would look something like this. So this is the sort of thing you'd want to stay away from if you're walking around on Triton. This is a close-up image right here, and you can see as the material goes up, it eventually gets carried along,
Whoa, that's weird.
yeah, by a jet stream. And again, that's only there because it has an atmosphere. Without an atmosphere, you would not see that. Another cute little image there. These are all, this is artistic stuff here. Not real images, same with this. Write this one down as well. We've got cryovolcanoes on Triton, in addition to cryogeysers.
Do you write the dashes?
Yeah, do the dashes as well. So as with most things, whenever you have something that is much larger, like a cryovolcano, it is not nearly as common as the small version, which is a cryogeyser. So yeah, pretty basic information there. And this is the last thing you need to write down for Triton. As you can imagine, those cryovolcanoes and those cryogeysers would have long since run dry if Triton was billions of years old. So we do have one more moon that we want to look at here that's going around Neptune. Before we do that, though, one more neat little artistic picture here. Again, this is not real, but they like to draw pictures of what these cryogeysers and cryovolcanoes would look like. This would be your cryovolcano. This would be your cryogeyser. All right, last one is Nereid. Write down this is the third from Neptune. You can skip this slide. So, named after sea nymphs. This is what popped up in Google when I typed in sea nymphs to Google Images when I first made this, so that's where that came from. You can skip that one. Write down how big it is, though. Diameter, 211 miles. You can skip this one as well, but it is cratered, rocky, and icy. This is a close-up image that was created using 3D software to kind of model what this moon would look like. You'll want to write this down, though. Highly eccentric orbit. And again, when I say it's an eccentric orbit, that means it looks not so much like a circle. So the orbit might look more like a big oval than a nice little perfect circle. That's what eccentricity is a measurement of. How much it doesn't look like a circle. We cannot see any of Neptune's moons from the Earth unless we have a gigantic telescope. If we have a big enough telescope like this, and we get a good view of it, this is about all we're going to see. So you just don't get very many features present on these moons, even though Triton is pretty massive. This is the best image that you would see. So, quick review. What's the first moon, the closest to Neptune? Very good. What's the next one? And then? Yeah.
Never.
Let's say that you're taking the quiz tomorrow, and most of the questions are basically, which of the three moons does this happen on? If that's what the question is, and you have no idea what the answer is going to be, what should you probably put down? Triton. Because there's a lot of stuff happening on Triton. There's not very much going on the other two places. And you got your family portrait. Quiz tomorrow.